In this video we are going to discuss about two very important graphs from this chapter. The first one is current versus potential, but the condition is that the constant, the intensity will be the constant and frequency will be the variable. So current means which current? That is the photocurrent, because suppose here when a light of suitable frequency is allowed to fall, what will happen? Some electrons will be generated or some electrons will be free from plate A. Those electrons will be pulled to plate C, and as a result in the circuit there will be a current, and that current is called photocurrent, and this is the photocurrent. And this photocurrent we are plotting along which axis? Along y axis. Along x axis we are plotting this potential. So potential means this is the potential of this battery. As you are increasing the potential of this battery, what will happen? The number of electron reaching to C will increase and the current in the circuit will increase. And remember that after a certain time the current in the circuit becomes same, constant. We call it saturation current. The reason is that suppose this light, it can make 100 electrons free. So those 100 electrons at a time will not reach to C. What will happen? As you increase the potential of this battery, the number of electron reaching to C will increase gradually. Suppose first 1, then 2, 3, 4, in that way all the 100 electrons, when they reach to C, what will happen? Till that point the current in the circuit will keep on increasing, but as all the 100 electrons reaches to C, the current in the circuit becomes constant and we call it the saturation current. In the graph we will definitely see this saturation current, but what are the condition? Now we have to understand what are the condition. One is constant intensity. If you remember, in video number 2 of this chapter we discussed about the relation between intensity and current, and I told you that as intensity of this incident light increases, the current in the circuit increases, because intensity means number of photons falling in the plate. So as the number of photons are more, it will eject more electrons, so current in the circuit will increase, right? But in this case what we are doing is current is being constant. So if current is being constant, though we are applying here three light waves of different frequencies, because frequency is variable. What are those frequencies? Nu 1, nu 2, nu 3. Three frequencies of three lights of these variable frequencies we are applying, but the intensity of these three lights are remaining same. So as a result, that means suppose for the first light, if it creates here 100 electron, the second light will also make 100 electron free, the third light will also make 100 electrons free. So after some time, when all this 100 electron reaches to C, we will get the saturation current, and for all the three light, the saturation current will be same, right? Okay, because their intensity is not changing, their intensity is same, only the frequency is changing. So as a result you can see that for the first frequency, means for nu 1, the graph goes like this and it meets here. Here means what? That is the this part is the saturation current. For nu 2, again it is increasing and it is reaching to this level, that is the saturation current. Again for nu 3 it is increasing, it is reaching at this point, that is the saturation current. Okay, but here you can see this is the positive x axis, and positive, along positive x axis we are plotting potential. This is the negative x axis. Negative x axis means we are plotting negative potential. That means negative potential means what? A negative potential at which the current in the circuit becomes zero is the stopping potential. Okay, so you can see here that for three light waves we are getting three different negative potential. One is V naught 1, V naught 2 and V naught 3. Now for this 3, why we are getting three different stopping potential? Means, see, for the first wave, when the first wave meets at this point, means when the potential is V naught 1, then the current in the circuit becomes 0. That is the meaning of stopping potential, right? So this stopping potential we are getting for three different frequencies, they are different. What is the reason? So you can see here, as we change the frequency, h nu is going to change. H nu naught is remaining the same, as it is the it is called threshold energy or work function, that is same for one type of metal. So with frequency, what is going to change? Only the maximum kinetic energy, and maximum kinetic energy is nothing but it is related to stopping potential. So in other word, as you change the frequency, what it is going to change? Not the current but the stopping potential. So as a result, you can see that for these three frequencies you are getting different stopping potential. Alright, so that is the reason why we are getting three different stopping potential but same saturation current. Okay, so this is for graph number 1. Then let us move to the next graph, that is this one, second graph. So that is also the graph between current versus potential, but the constant is the frequency and variable is the intensity. You can see here these three intensities are taken, I1, I2, I3. Now as we know, since the intensity is changing, what will change with that? Saturation current. So see here for I1, when the intensity is I1, this is the saturation current, this one, the height of this is the saturation current. For the next intensity I2, this much is the saturation current. Okay, for I3, this much is the saturation current. So with intensity, saturation current is changing, but yes, since the frequency is same, frequency is constant, they all the three lines are meeting at the same stopping potential, which is V naught. Okay, so I hope it is clear. One more thing you remember, the order. I1 is the less intensity, so the graph is the lowest one. I3 is the highest intensity, graph is the upper one. So as you increase the intensity, the graph is going higher and higher. Okay, similarly like the previous one, just a second, okay, this one. Here also you can see the order of the frequency. New one, new one is the least frequency. For new one we are getting the lowest line. New 2 is the next frequency, the middle line, and new 3 is the highest frequency, we are getting the highest line. So in that way, as the frequency increases, the lines will go higher. Alright, so these two are the graphs, very important graph related to this chapter. In next video we are going to discuss about de Broglie's equation. Thank you.